Hey Matrix, welcome to the second video of the chemistry past paper. Today we'll be doing question 3. If you don't have the paper, there's a link in the description below, so you can pause the video, download the paper as well as the memo, and once you have it then we can continue. Okay, let's get started with question 3. So question 3 tells us, we can first of all see that there's a graph. So at the top it says the relationship between the boiling point and the number of carbon atoms in straight chains molecules of aldehydes, alkanes, and primary alcohols are investigated. Curve A, B, and C are obtained below. Okay, so if you get something like this, the best is draw out what we're looking for. Okay, so we're looking for aldehydes, alkanes, and primary alcohols. So I've done that over here. Okay, aldehydes have a double bond on the carbon on the end of the chain. Alkanes have just single bonds between all the carbons, and then a primary alcohol has the OH bonded on normally the N carbon, because then there's only one carbon attached to another carbon. Okay, so just go and check your definitions for that. Okay. Second of all, we can see that we're dealing with boiling point, and then at the bottom here it says number of carbon chains. Okay, so we can see that it's an exponential graph, similar to or very similar to an exponential graph or a logarithmic graph, and so on. Okay, so let's have a look at question 3.1. Asks for a definition of your boiling point, so you can go and check your list of definitions for the exact wording of that. Okay. Then for 3.2 it says write down the structural formula for a functional group of the aldehydes. Okay, so remember an aldehyde has the double bond oxygen on the end. So a functional group, okay, is responsible for the characteristic reactions of the compound. Okay, remember your definition for that. So the functional group for the aldehydes, okay, on the side here, is going to be our carbonyl groups. Okay, remember our carbonyl groups is a carbon with a double bond oxygen to it. Okay, then question 3.3 says the graph shows that the boiling point increases as the number of carbon atoms increases. Fully explain this trend. Okay, so I've broken it down into 3 things that we can look at. Okay, the first one is, first of all, what is happening? Okay, the second one is the effect of this happening, and then lastly, what is the result? Okay, so normally when we're talking about boiling point and we're talking about energy, okay, because we need energy for something to boil. Therefore, we're talking about intermolecular forces as well. Okay, so first of all, the first thing that's happening is we have an increase of carbon atoms. Okay, so we have an increase of carbon atoms. Okay, and due to this, what is happening? Okay, so the first thing that we can mention is the molecular mass. Okay, that's increasing, or the size of the molecule. Okay. Okay, the chain length. Is increasing, or you can say that the surface area is increasing. Okay, so this is what's happening. We've increased our carbon atoms, number of carbon atoms. Therefore, either one of these you can mention is happening. Okay, then what is the effect of this happening? Okay, so because of this, there's an increase in intermolecular forces. Okay, so there's an increase in my intermolecular forces. Okay, in this case, if we because we're dealing with aldehydes, alkanes, and alcohols, okay, the main intermolecular force here that is going to be increasing is there's going to be more places for London forces to exist. Okay. So London forces. Okay, that's between our carbons and our hydrogens. Okay. It can also be between your carbons and your oxygens. So the last thing is, now what is the result of this effect? Okay, so the result of this is there's more energy needed to overcome my intermolecular forces. So I need to increase my energy to overcome the intermolecular forces. So because of I need to increase the energy, what's going to happen? My boiling point is going to increase, and that's why the graph looks like it does. Okay. Now, for 3.4, it says identify the curves A, B, and C that represent the following. Compounds with London forces only. Okay, so we're only looking for London forces, nothing else, no other kind of intermolecular force. Okay, so by looking at the graph here, London forces only are our weakest forces. So because it's the weakest force, we need less energy to reach boiling point. So can you see that the graph C over here has the lowest energy? We're starting at 173 Kelvin. Okay, and we only go up to 373 Kelvin. Okay, so therefore 3.4.1 is C. Okay, so C has only London forces. The next one says 3.4.2, the aldehydes, and explain the answer. Okay, so now when looking at which one is our aldehydes, okay, just a quick one here. Alcohols have hydrogen bonds. Aldehydes, okay, there's an E missing, is dipole, and London forces. And then our alkanes are just London forces. So we can see here that C is alkanes. Okay, and the one with the highest boiling point has to be our alcohol. Why? Because of the hydrogen bond. So therefore B has to be my aldehyde. Okay, so the answer is B. Okay, why is it B? Okay, this is due to the double bond oxygen. Okay, so we have a carbon with a double bond oxygen on the end. Okay, that double bond oxygen means we've got the dipole forces as well as the London forces, okay, which makes the forces slightly stronger. So due to that, the aldehydes have stronger intermolecular forces, okay, compared to our alkanes. Okay, but it is lower than the alcohol. Okay, so because it's lower than the alcohol, there is more energy, okay, needed than the alkanes, but less than the alcohols. Okay, so that's the explanation for why B is my aldehyde. Okay. Then, looking at 3.5, it says use the information in the graph and write down the IUPAC name of the compound with the boiling point of 373. Okay, so we go here, we look, we can see that 373 is over here, it intersects the graph, so we have 4 carbons. Okay, plus it's on the B line, and B we've just determined is our aldehydes. Okay, so the suffix for aldehydes is an L, and there's 4 carbons. Okay, so therefore we have butanol. Okay, so we have butanol. Then for 3.6, it says write down the IUPAC name of the compound containing 5 carbon atoms, which has the lowest vapor pressure at a given temperature. Okay, so remember the definition for vapor pressure? It is the pressure where the vapor above the liquid exerts a force on the liquid. Okay, so what that means is for boiling point and vapor pressure are inversely proportional. Okay, so if boiling point increases, okay, it means my vapor pressure must decrease. Okay, because if I have a high force on my fluid, then I have a low boiling point. Okay, but if I have a higher boiling point, then I have a lower vapor pressure. Therefore, we're looking at A. Okay, and A is my alcohol, and it's a primary alcohol. Okay, so we're looking at number A, and it asks us again the IUPAC name of the compound given with 5 carbons. So if we go up from 5, we're looking at A because it has the higher boiling point. Okay, so 5 carbons means pent. Okay, we know that A is my alcohol and it's a primary alcohol, so the OH is on the either end of the carbon chain, so therefore I've pentan 1-ol. Okay, so with this section you need to know your theory extremely well in order to understand the questions. Okay, and that's how we go about doing this. If it's helpful, please leave a thumbs up on the video. It does help a lot. If you have any questions regarding the section, please leave them in the comment section below. Let me know what you think about the videos as well. If you have any queries regarding anything, or if you have any suggestions, let me know in the comment section below as well. And thank you for watching.